So for this assignment, I picked the 14th challenge, which is the question that to construct a FSM for entering a security code into a ATM machine. So code here is the first thing I do is import the pandas and the regular expression, those two modules, and for this challenge, I created this two state table that will be taking care of. The first thing is the validate the length of the password. The password length has to be 4 digits, and the second table is to be taken care of, is used to take care of the validation state of the password. If it's a valid password, it will return a as a state. If it's a locked state, it will return as 7. If it's returned as 5 or as 6, it will be a failed status message to be returned. And I here using the Panda data frame to display the state table of these two tables that I'm going to use. These two state tables to implement the finite state machine logic for this challenge. The second thing I did is to define two different functions for these two different tables to parse the final state to a human readable name, which is for the validation finite state. It will return either success, locked, or failed. For the password length state finite state machine, will either return complete or incomplete. So I have defined two big classes. The first class is the ATM class. When this ATM class gets instantiated, it will have two methods. Add digit method is to simulate how a user will face the interface of a ATM machine to enter a digit enter one single digit at a time. So a user will need to input /enter 4 times to completely finish entering a valid password length. For this digit method, it will print out the password it entered through the interface. It will call the start transition, the password length state table, and it will also call the parse method again to parse the state to a human readable message. Unconfirmed method here is to simulate how a user will need to click a OK button to confirm finishing entering the password and allow the machine to validate the password to determine whether to go to the next screen or allows the user to re-enter the password. So for this method, it also calls the start transition on the second finite state machine implementation of password validation. So for this unconfirmed, I have a if else block that further filter out unnecessary status. If the password is not complete, which means the user hasn't completed entering the password, it will go to the else block. And all of that, if the status has been locked, it will also prevent the user to further entering password again. So for this if block here, it actually will look through different attempts to make sure that no more than 3 attempts can be executed in one instance of this ATM machine. And for this class, FSM machine, this is the class that implemented the logic, implement a similar finite state machine logic. When this FSM class being instantiated, it will read the state table passed in, and it will have this method that will eventually be called inside of this class. So here in this cell, I have a input that let's say the valid password is 1234, and I'm going to run the 3 test cases, and each test case is here that for the first one, first instantiate the ATM machine and then simulate how the user will enter the digit, one digit at a time. And after finishing entering the password, it will run the unconfirmed method. So for this first test cases, if we run it, it will say here that for each method execution, it will print out the result for each one. So after 3 failed attempts, the final status for this ATM machine will be locked for this user. And the second case is here that for the second time, it actually succeed the password. For the third test cases, I forgot to call the unconfirmed. And that is failed. Cool. And this is my walkthrough of my software challenge solution.